Good morning to all. In this course PH8151 Engineering Physics, we are going to learn about Unit 5 Crystal Physics Module 4. I am G. Indra, Assistant Professor in Physics, Government College of Engineering, Tanjavur. In this Module 4, we are going to learn about growth of single crystals. In this Module 4, we are going to study about the formation of single crystals, what is solidification and crystallization process, then the different type of crystallization of compounds like cooling method, evaporation method, vapor diffusion method, liquid diffusion method, sublimation method, and we are going to learn about the melt growth techniques like Zaralski technique and Bridgman technique. Next, we are going to learn about the solution growth technique, low temperature solution growth techniques like slow cooling, slow evaporation methods, temperature gradient method, and high temperature solution growth technique like hydrothermal growth and gel growth method. Learning outcomes of this module. At the end of this module 4, a student must be able to describe the various techniques applied to grow single crystals. Students can be able to explain the melt growth techniques such as Bridgman and Zaralski technique. Also, the students can explain the solution growth techniques such as low temperature solution growth techniques and high temperature solution growth techniques. First, let us see the formation of crystals, single crystals. So, crystals are nothing but solids, but it is different from normal solids. So, in crystals, the atoms, molecules or ions in the crystals are arranged in a periodical manner or repeated manner. So, in all the three dimensions, the atoms arranged in the equidistant manner. So, forming a crystal is nowadays it is an important useful needful one, since the crystals are applicable in electronics. All of you know diamond structure, that is well known crystalline structure in like ornaments, diamond, ruby, emerald and all crystal structures. Apart from that, the crystals have wide application in the field of electronic devices. There are many methods to obtain a crystals. The crystals find variety of applications in electronic devices. Next, let us see solidification and crystallization process. Look at this picture. In this picture, the graph between the temperature means the temperature to time of cooling. The temperature started decrease. Usually, a material can be exist in three different states that we know very well. One is solid state. When you heat the solid at element high temperature, it started melting at a particular temperature, that is called its melting temperature. After that, the solid phase is transformed to liquid phase. After that, you continuously boiling, you continuously heating the material. At one time, all the liquid become vaporized, that is gaseous state. So, a material can transform to these three states. So, this figure explains the relation between the temperature and the cooling time. When you look at this figure, the cooling time increases. At a particular temperature, the process of crystallization begins at a particular temperature. So, the crystallization process depends on the cooling time. The temperature of the material here which means the the materials is in liquid state, which means if you, when we think about the silicon or germanium like semiconductors, that should be in melt form, that is liquid form of the material. So this is, here it is in liquid state. When you decrease the temperature relatively with the cooling time, the cooling time gets increased at a particular temperature, the material becomes crystallized. So after get crystallization, the atomic arrangements, you can see the difference here. Here the atoms are not in periodical manner, but here it is repeatedly arranged in a periodical manner. So this is crystallization, crystallized. So up to this particular region, the crystal we can get crystals. So based on this, the crystal growth, the crystals are grown from grown from melt also. Melt means nothing but it is a polycrystalline material that is taken inside the holder or crucible. It is heated. One important thing is the polycrystalline material, the crucible is taken or the holder is taken in such a way that should not react with the material which is to be heated, that is inside there. So when the crucible is heated, the molded material is cooled by slow cooling method. At particular extent, we will get a perfect crystal. Next, crystallization of a compounds. The crystallization of a substance can be achieved based on 5 different methods, which are cooling method of a saturation solution, evaporation method of a solvent, vapor diffusion method, liquid diffusion method, sublimation method. In cooling method, the cooling method is the method for crystal growth, that is a very successful one, and this method is a simple method. In this method, in this cooling method, the cooling of saturation solution. The saturation solution means here the substance that is to be crystallized is taken in a like a solid form like salt or something, that is dissolved in a liquid, that is called solvent. Say a solute or a substance that is to be crystallized, that is dissolved in a solution, that is usually known as solvent. So a saturation solution of a compound, the saturation solution means we are adding the samples into the solvent and we will stir it, it will get dissolved. We are adding more solvent, some more solvent, we will stir it and it will get dissolved. So at particular time, at particular stage, you are adding the solvent into the, you are adding the substance into the solvent. When you stir it, it will not get dissolved. So in that particular stage, if you heat the solvent, it will get dissolved. So when you increase the temperature of the solvent, you can add or you can dissolve more amount of substance into that solvent. So in such a way that a super saturation solution is produced. So cooling a saturation solution of a compound that is to be crystallized. So finally we will cool this saturation solution and you will get a fine crystal as the end product. Next, evaporation of solvent method. The evaporation of solvent method is the most common method for crystal growth. In the evaporation of solvent method, the solvent from the solution is get evaporated and the crystal is deposited at the bottom of the beaker. So in this method, a saturated solution is taken. The solvent that is containing the solute, the solute is the compound that is to be crystallized. So in the saturated solution, the solvent is evaporated. So due to this due to this evaporation process, the fine crystal is collected at the bottom of the holder. So this method is called the evaporation method. Next, vapor diffusion method. The vapor diffusion method is one of the popular and most successful method to grow crystals of a macromolecules. The vapor diffusion method is a common technique that is used to crystallize protein molecules. The principle of this vapor diffusion method is a drop that composed of a mixture of sample and the reagent that is placed in a vapor equilibration with a liquid reservoir of reagent. So typically this drop contains a lower reagent concentration than the reservoir. So due to this concentration gradient, deriving vapor to the reservoir. So this causes the droplet to shrink and the crystalline sample is collected from the droplet. Next, liquid diffusion method. The liquid diffusion technique involves the slow diffusion of one solvent into another. So in liquid diffusion technique, the two solvents that are added to a vessel as lower density solvent on the top of the tube and the higher density solvent at the bottom of the tube. The solvent from high concentration side is diffused through the a layer between the two solvents, and it will diffuse from high density side to the low density side. So due to this diffusion, the crystal is deposited at the bottom of the tube. So this method is called the liquid diffusion method. Next, sublimation method. The sublimation method is a useful method for growing crystal from vapor, and it is called the physical vapor transport method. The raw materials in this method, the raw materials are heated in a crucible and sublimated in a high temperature zone. So in that high temperature zone, the material get vaporized. These vapor transport to the seed crystal in the low temperature zone. So in this way the crystal is formed in sublimation method. I will continue the melt growth, crystal growth from melt in my next lecture. Thank you.